that everybody here that has some background or not on programming can understand a little bit better the core concept of what programming is, how it works, also why it's so important in today's world. Programming is everywhere, application, websites, everywhere. We live in a digital world. So we'll touch on some of the core topics about programming to give you also a flavor on what we do at Le Wagon. So Le Wagon is actually a coding school created in Paris a few years ago and quickly grew to be one of the first rated coding school in the world. And we help students reinvent their careers with technology through immersive bootcamps in web development and data science. So we basically do full stack development bootcamps, which are 9 weeks very intensive programs to teach our students that come from all walks of life. You have entrepreneurs, you have former corporate people, you have geography teacher, you have plenty of different profiles that come to our bootcamps to learn the basics of web development, to reinvent themselves, so to become entrepreneurs, to become product manager, to better understand how developer teams work, or to become a developer themselves because they want to work in tech, because they want to become freelancers, etc., etc. So today, actually exactly today, we marked the 6,000 alumni. So we have 6,000 people that went through our bootcamps globally. We are in 36 different cities in the world. Stockholm is the latest city to be launched, actually. We are just starting here. And I will tell you a little bit about our bootcamps later on. We've built more than 1,500 applications, and about 300 startups have been brought to life as a result of what we do. So we don't just tell you that we are the first ranked bootcamp. Our Net Promoter Score from our own students is quite high, and it's consistently rated as such on the web. And why is that? Because beyond a bootcamp and hard and soft skills, what we offer is a life-changing experience. And instead of me describing that to you, we're going to watch a short video together about that.
Welcome to the demo day of batch 222 of the Wagon. We're extremely happy today to be here to celebrate the start of a new journey of our 41 students graduating today and joining the Wagon community.
My name is Leticia Akawe. I'm 22 years old. After graduating, I noticed that I don't have enough technical skills. I took a coding class in university and I liked it. Then when I looked into boot camps, I saw that Le Wagon had really good reviews, so I applied.
My name's Kitty, I'm 25 and I used to work as a teacher in North West London before I decided that I wanted my teaching to actually stretch beyond just the classroom and I wanted to start a career in educational tech. So I quit my job and I started the course at Le Wagon.
I'm Henri Navassel. I've been in digital for 20 years. So I worked for companies like HSBC, Johnson & Johnson, Pfizer, Google. I chose to do a bootcamp because I have a very busy lifestyle. I have 2 children and a family to manage. But it's been an amazing opportunity for me to revamp my technical skills. You need your customer journeys to be extremely relevant and integrated with your digital product. For that reason, I really need to understand the whole path.
You go online, you choose the city where you want to learn, fill a form, and then they give you a Ruby exercise to do. Once you finish the Ruby coursework, you get an interview with the city manager. I was so excited of doing it while applying. Like even the coursework, I found it so fun to do. It was really exciting.
So I was really excited on the first day to meet my peers and the people I was going to be learning with. There are people from Morocco, France, Italy, Spain, the US, South Africa. Doing the bootcamp learning on my own made me really appreciate the fact that I was signing up to a course with other people because actually learning independently is really difficult. It's very difficult to motivate yourself because if you hit a problem and you're on your own, it's almost impossible to resolve without hours and hours of thinking.
Every single day we spend in Le Wagon is about learning something specific, and everything's very incremental.
I think the best thing that you can all do today is forget about all of that.
In the morning we have a lecture, and in the afternoon we're doing coding that matches the lecture that we had in the morning, and it also takes into account the previous lectures that we've had. Le Wagon not only explains to you how technology works today, they also give you the education to go and find the information yourself.
Our flagship program is a 9-week full-stack web development course. Full-stack means that we teach candidates how to go from having an idea all the way to building a fully functional web application. For the backend, we teach Ruby on Rails, front-end, HTML, CSS, JavaScript, which is very popular.
So far it's been harder than I expected, but also really rewarding.
It's been really interesting to work alongside people with so many different experiences. There are some people who've come straight out of school, other people who've had top banking jobs, there are lawyers, there are creatives, designers. We've all got something in common, which is that we are incredibly motivated and we're here to learn together.
Learning to code is being autonomous. You have two ways to behave in front of new technologies. You can be a spectator, you can use Facebook, use Google, you use them as tools, or you can be an actor and you can create your own tools and understand how these tools work.
Anyone can achieve these objectives, be it landing a job in a tech company, as a developer, working in a tech-related role, as product manager, or launching a company as an entrepreneur.
All of the steps that angle towards building a product at the end of the course. It's so nice to be based within a team. When you're working alone, it's very easy to get sort of stuck on little issues, but when you're working together, you talk them through and you realise where you're making mistakes, so that's really nice. There's a real sense of a collective struggle, and that brings them together as a group very, very quickly, and developing a very strong sense of what it really feels like to develop a product in the real world. And that has been really, really, really valuable to me.
I was doing the front end for our website, and the hardest part for me was to go from having nothing to having a web page with components and cards, taking the stuff I learned during the bootcamp and building up on it.
Welcome to the demo day of batch 222 of the Wagon. Tonight we're going to discover the applications that they developed.
Hi everyone, my name is Izzy and I am a geography teacher.
The reason we built sessions was because we feel as if mental health is really important.
The problem is I've got lots of friends, but they're far more into capriners than carabiners.
If I was to describe Le Wagon in one word, I would choose the word entrepreneurship, because people care, are hands-on, and they want to solve problems. So I definitely think that the training I've received at Le Wagon is going to help me be hands-on, but most importantly, continue to learn and to stay on top of things.
If I had to describe Le Wagon in one word, I would say it's motivational. I'm a lot more confident now, and I think I can find a job in tech. I think having Le Wagon as an experience is going to help me a lot find the job I want to do.
If anyone is concerned about whether or not they should apply to Le Wagon, if they think it will suit them or not, I would say come to Le Wagon's events. There are so many. Come and visit the school. It's just a really formative experience, even just for your professional development. If I could describe Le Wagon in one word, it would be a revelation.
So actually what was not on that map is Stockholm, and we are just starting in Stockholm. But why Stockholm? Stockholm is actually one of the biggest tech hubs in the world and in Europe, a leading tech ecosystem. And there's a major issue ahead of us in the city, is that it's fast growing, but there's a huge skill gap. That means the tech industry in Stockholm is growing so fast, and there's so many startups being developed, that the skill gap for tech-related skills, especially development skills and coding skills, is increasing so much. That means people are really struggling to find developers. For us, we see that as a massive opportunity to fast-track the education of people that come from very different walks of lives, as you can see on the video, and offer really solid job opportunities as a consequence. So we've been trusted with a lot of the big ones. I'll go fast on this. We've built a bunch of applications. A lot of them today have become actually startups. We raised the few companies that were created out of Le Wagon raised about $65 million in seed money. And we have a couple of success stories. Again, I'm happy to discuss that in more details, but I want to make time for the workshop. Today, it's a massive community. And when you do the bootcamp and you enter Le Wagon, it's not just you do 9 weeks and then you go home and you don't hear about those people anymore. You're part of a lifetime community where you have access to our educational programs, our Slack, and our network everywhere globally. So if you move to, I don't know, Bali next year, you can actually connect to your Le Wagon alumni there, find a job, find a freelance project, that kind of things. So we are really global. We are all about program mindset. So we teach in the 9 weeks of the bootcamp the equivalent of 3 years of traditional computer science degree at university. So we're all about fast-tracking your education, and we're all about product. Code is here to build products, not just theories. We learn something, we apply it right away. And this is really the idea behind the bootcamp. You learn a lot of skills. Soft skills, because you have to collaborate as a team of developers. The cliche of having a lone developer in a corner working on his own is absolutely a myth and overrated. Today, a developer, someone that works in tech, has to collaborate. That's why those social and soft skills are so important. But we teach you a lot of hard skills. How to build robust software that will actually survive just a minimum viable product, building tests and coding environments. A lot of design as well. A tech product is not just something that works, it's something that is appealing, it has a call to action, that enrolls people in something that can become more than just a visit to your website, but engaging with your potential consumer. So UX and UI design is really important. Collaboration and tools. We also teach you how to collaborate on DevOps frameworks, let's say like GitHub or GitLab, how to collaborate with other teams of developers to build tech products. So we don't teach code like traditional computer science degree. We teach by doing stuff every day. So again, lifetime access material, live community. I will go really fast on that to make way for the workshop and Gustaf. But how can coding change your life? And I came up with that chart myself after doing the bootcamp. Coding is freedom. If you're tired of the 9-to-5 job and you want to do something else, become a freelance, work from anywhere, coding can enable that. If you have a business idea, if you're a creative person and you want to give life to that idea, coding can be an answer for that. Empowerment. We are all about empowerment. That means giving you enough tools to build your own career and to build potentially your own business. It's a massive intellectual challenge. Myself, I'm not at all an engineering guy. I never did coding before the bootcamp. And I had to stretch my brain really hard to understand some of the concepts that actually Gustaf will teach this evening. But it's so rewarding. I was way smarter after 9 weeks than when I started the bootcamp. And it's a constant learning. Coding teaches you humility because it's not easy and there's always something else to be learned. But you can have an immense opportunity to keep learning once you have the basic tool and you understand how coding works. And it's also a huge tool for being more independent and autonomous. It can also change your life if you want to fast-track your education and start to work in tech. Those are some figures that we took from the UK because we're just starting in Stockholm. So ideally in a few months, I can give you some data on Stockholm. But attractive entry-level salaries, a very high percentage of people that find a job right after the bootcamp, and a very short lead time in doing that. So, without further ado, this was Le Wagon. I'm happy to answer your questions after the workshop. I'm here. My contact information will be provided to you. But I want to introduce my friend Gustaf, who will actually run the workshop tonight and will be introducing you to the beautiful world of programming. So, thank you, Gustaf.
All right, thank you. All right, can anyone hear me? Yeah. I think we're good. Okay, cool. Yeah, just a short introduction to myself before I start introducing you guys to programming. I actually graduated business school a couple years back, so I spent some time working in tech startups, mainly in business development and sales. But I've always had this kind of itch to learn more and understand various tech products on a deeper level. So ultimately, this last spring, I actually quit my job and I moved to Montreal, and I did a boot camp in Montreal. And it was a really great experience, and among other things, I learned that French is impossible. Fortunately for you guys, coding is not. So we're gonna go through this core concepts together, write our very first lines of code. Whenever you have any questions, feel free to raise your hand or interrupt. I'm here for you guys, so if something is not clear, let's get that straightened out right away. So, starting out with just a definition, what is a programming language? Well, basically it's a formal language, like any other, with vocabulary and set of grammatical rules, enabling us to instruct the computer to perform specific tasks. So, respecting this kind of grammar and vocabulary is very important. Just like any other written or spoken language, if you want to be understood, you need to make sure that you respect the syntax and the kind of structure of that language. I'm going to introduce you to 3 different languages, just a very brief overview. Here are 3 very popular ones, JavaScript, Ruby, and Python. JavaScript and Ruby are big parts of the Wagon bootcamp. Python is not, but I wanted to mention it anyway, since it's a very trendy language right now. So JavaScript, I guess a bunch of you guys might already have heard of it. It's the only language that kind of runs in your browser, so your Safari, Firefox, Chrome, when you're browsing the web. JavaScript is actually running in the background in most popular web apps. So it enables us as developers to write really interactive, dynamic websites, pages that can actually change even though they're loaded. So as an example, if you go to Facebook or Gmail or any kind of app, you'll notice that the page loads, you get your content, but then it will update dynamically, right? You will get your notifications, you will get your chat, you will get all new kinds of data as you scroll in your flow. This is all due to the magic of JavaScript. So in the background, in your browser, JavaScripts are actually fetching data, like asking Facebook servers, for instance, all the time. Like, is there new stuff, basically. And another really important thing to know about JavaScript, it's not related to Java, the other language, whatsoever. They're just happen to be named in such a way. They're not related any other way or form. And JavaScript is super, super popular, so it's a good thing that it's taught in the bootcamp. Ruby, which is the kind of main language in the Wagon bootcamp, was designed in the mid-90s, so it's a fairly young language, and it was designed following a principle of kind of least surprise, meaning that it should be easy to understand the output and the kind of both readability and reading and writing the code. It's a very, very good place to start for those reasons. And it also has a lot of community support, so there's a lot of what we call libraries and frameworks, which are basically existing code out there that we can reuse for free as developers, enabling us to build really amazing things very rapidly. So instead of reinventing the wheel, there's a lot of stuff out there already. Python, a bit older, it's from the late 80s. And it's had kind of a renaissance in recent years due to the fact that it was widely used in academia among mathematicians and statistical people, I guess. I guess all of you are familiar with the term ML and AI, like machine learning and artificial intelligence. And due to those things becoming so incredibly popular, Python has had kind of a renaissance. And it's also kind of a good place to start because the syntax is similar to Ruby in a way that it's easy to write your first lines of code, and it's somewhat English-like. I'll show you 1 or 2 examples of this in a while. Right, as programmers, we have our toolbox, our set of tools. We usually refer to something as called the IDE, our Integrated Development Environment. So typically this is whatever we run on our computer to kind of write, read, and execute our code. And in the most basic form, we would have these 2 key components here. A text editor, which is basically just a way to read, write, make comments, like store your code. So it's kind of like a less fancy version of Microsoft Word with the added benefits that you will have keyword highlighting, it will autocomplete for different languages, alert you if there's like an obvious syntax mistakes, those kinds of things. The terminal, different operating systems, it might be called console, command prompt, different words, same thing basically, enables us to both interact with our computers, create, move files, execute code, while still in like a command line interface. So it's, in a lot of ways, your entire computer without the graphical interface. We're going to stick to these tools here tonight. So this is actually the logo of Sublime. So Sublime is the text editor that Wagon uses, and I actually stuck with it because A, it's free and it's really good. And then we're going to use the terminal to kind of run our code and see the results it yields, basically. Right, so we're going to go through a few core concepts that are going to hold true for any language, and I'm going to focus a bit more on Ruby here tonight, just so we have some like consistency and we can get a bit more into a bit more complex stuff without drowning you with different syntaxes. So variables, they're going to be a part of any kind of language, and they're very important, so it's very important to understand them deeply. And they're basically a storage location identified by a name. So one way to put this could be that you have a box, right? You have a box with a name on it, and that would be your variable encoding. We can put different things in our box, and we can like reference or get the content of our box by its name. So I think this might make it a bit clearer. This is a standard spreadsheet, right? So we'll have the different cells, or boxes, if you will. They will have different names, and they can contain different values. So in a lot of ways, this would be a variable. Right, so in cell A1, or variable A1, we have the number 5. So the variable stores the number 5. So we have put the number in the box, in the variable. Same with B1. So we have number 7 in our box. And then in C1, we're performing some kind of mathematical operation to just add the two together, like adding variable A1 and B1 together and storing the sum of that. And how would we actually go about coding this? So I'm going to show you examples for all 3 different languages that I mentioned earlier, so Ruby, JavaScript, and Python. And you're going to see that they're not that different after all in the very basic form here. So here, this is a site called, you can't actually see the full picture, but it's called repel.it. And this is a web version of what I mentioned earlier, the IDE, the Integrated Development Environment. So there are a lot of good sites like this where you can basically go, you'll have your text editor on your left and console on your right. And this will enable you to like write some basic lines of code and test it out in different languages without having the Sublime or like opening your console locally on your machine. So this is actually a fun way to kind of get started with writing your first line of code. There are more than repel.it. There's a bunch of different sites for this. So in coding, we always stick with the kind of execution from top to bottom. And in a good text editor, it would be line marks. So we have lines 1 to 5 in this case. For the first line, we're first defining a variable, A1. We're using the equal sign, except it's not technically an equal sign. It's something called the assignment operator. So we're assigning something to this variable, to this box. In this case, it's a number. It's number 5. And for some people, it makes more sense to kind of read it right to left. So we have the number 5 using the assignment operator. We're putting it in our variable, the box, which is named A1. Same with the second line, A2, assignment operator, number 7. And then in line 3, we're adding them together, right? And then in line 5, we're using a keyword in Ruby called puts, which is basically a keyword that will print to our console or the terminal right here. So if we run this code, you will see that it outputs 12, which makes sense because we have added 5 and 7 together through the variable A3. Makes sense, right? Yeah. All right. In Python, very much the same story when you're defining variables. Nothing different at all. The only difference in syntax here is that instead of puts, we're using the keyword print, so it's even more intuitive. And then instead of like just having a space and the name of the variable, we have it in parentheses. But again, it's very much the same thing. JavaScript's a bit different. Here we'd actually have to declare our variables with a keyword. So here we're using the keyword const, which is stored for constant, meaning that this variable gets declared and it shouldn't change, right? It's a constant, just in math, right? It shouldn't change. We shouldn't reassign this value down the line. And then we have the kind of semicolon at the end of each line, which in JavaScript means that we're telling the language we're done with this kind of operation. We're done with what we want to achieve here. You can move on to the next one. And in some cases, this is optional. In some cases, it's not. So it's very good practice to kind of have those semicolons. The other difference is that instead of puts or print, we're using console.log, which the kind of keyword and the methodology of logging something to the console in JavaScript, and then in parentheses, our variable, and of course it would return the same kind of result. Right. So we can go through a few data types, and then we'll actually open up our Sublime and code some different variables, and you'll see how it actually looks in a local environment. I'm going to use Sublime text. We're going to run different code in our terminal. But I'm going to cover some data types first. So now you saw one data type in those variables. It was all numbers, right? Well, as it turns out, numbers can actually differ too. So in JavaScript, for instance, numbers are just numbers. Doesn't matter. In Ruby, however, we actually separate the two between integers and floats. So a full number, like 3, would be an integer, and a decimal point number, 3.14, would be considered a float. So why is this important? Well, of course, if we're going to perform some kind of mathematical operation, like division or comparing something, we need to be aware of what kind of data types we have. So it's really important to know how you're storing your data and your variables, and we're going to see this in just a second. So that's number. That's a huge part of programming and variables, actually. Strings, a sequence of text or characters, usually text. It's a way to store any kind of information, usually in quotation marks. And we're going to declare a few strings in a while and do some different operations on them. Booleans, which are going to become a big part when we get into conditionals. So if you've ever heard of like an if statement, if we're checking if this is true, execute this. If not, do something else. So whenever we're asking a program to kind of evaluate something through a conditional, it will always return a Boolean. Either it's true or it's false, never something in between, right? So those are really important to understand as well. Great, so I have my terminal here on the right. So now I'm actually on my desktop. So this is my normal desktop. And then I can actually like display files and so on. But for now, I'm actually just going to make a quick folder so we have something to store our files. I hope. All right, so this is our text editor here on the left. This is Sublime. So basically, it will have line-by-line marks, which is a great. Oh, you can't see that part. That's great. There we go. Which is a great way to, of course, keep track of where you wrote what, and if you collaborate among fellow programmers, like you can tell them to have a look at line 5 or whatever. So it's a good kind of reference point. This is also very important. Like in, oops, should open my file. It's a good start. We can make comments, right? So this is a comment. It's good to know because I'm going to write a bunch of those. So whenever you have a hashtag in Ruby, it means that this is not going to be executed. This is just a comment, which can be useful for even leaving notes to yourself or to when you're collaborating with something. You can tell your fellow programmers that this is going to do this. So comments are really important. So now, if I wanted to assign a variable, I could name it whatever. So using the same example as before, I could name it A1. We can use the assignment operator. I can put any kind of value here. We could use the number 13, for instance. And now, in our terminal here, we could tell Ruby to run our program. So Ruby, and then my program is just called program.rb, RB short for Ruby. And if I were to run it now, nothing would actually happen that we see here in our terminal. The program would still run. It would define a variable. It would use the assignment operator. It would store the number, in this case the integer, because it doesn't have a decimal point, in that variable. But nothing would be kind of printed or returned, because we're actually not doing anything with that data. So in order to do that, I could use the keyword puts we saw before. We could put A1, and now if I run it again, it would actually return 13. Let's do another one just to show you the difference between integer and float. So same thing, we run them, they return the same kind of value. But if I ask Ruby, like, what type of data is this? And in Ruby, it's called a class. But what data type is this, actually? We could add the dot class here. And as you shall see, Ruby actually tells us, well, the first one is an integer, the second one is a float. So really important to make sure you keep track of your different data types and how you store them. Right, if you wanted to have a string, you can store it in a variable called myString. Use the assignment operator again. We'll write something. And we could put that to the terminal as well. Right, so now we have basically just defined a couple of variables. We have stored some values using the assignment operator in those variables. We have made an integer, a float, and a string. That's basically it for now. All right, any questions so far? Pretty straightforward, right? Yeah. I'm going to show you two more concepts. They're going to perhaps come across as a bit advanced at first, but they're really useful, so I want to show them already tonight. After those two, we're going to do some exercises, and we're actually going to put more of this into practice. The first one being an array or a list, which is, as it says here, a collection of elements identified by an index. So basically, an array is a list of any number of elements. Say we have an array that ranges from 1 to 10, so it has 10 elements. It's really important to mark or note here that the index would actually start at 0. So if we want to reference our first element in our list, we would use the number 0 when we ask the computer for, like, fetch us the first kind of element. So that's really important to know. Now, okay. And we could use comments again to, like, if I don't want Ruby to execute this line here, because I don't want this to be put or printed anymore, I can just prepend it with a hash sign here. And it, like, grays out and basically won't be executed. But it's there if you want it back later. So, an array is known by its square brackets, like this. So now we have used the assignment operator to kind of assign an empty array to this variable, our first array. And of course, even an empty kind of data type is still a valid data type. So we could use this, we could declare a variable or define a variable, and then you store an empty array in this. And as you shall see later on, it might actually be useful to sometimes have an empty list in case we later on want to store something in that list. But we could, of course, store any kind of data in here, so we could store a bunch of names, right? And then if I were to put my array, we would now get the entire, like, element by element that's stored in our list. And remember that the indexes start with, let's comment this out, start with 0, 1, and 2, even though it's basically 3 elements, right? And whenever we want to reference use one of them, we can use a square here as well. So whatever number I put in here will actually be the index at which the element is sitting. So in this case, if I wanted to put the name Eric, what number would I put in my, it's actually a bit small, we can do something like this. All right, so I want to put the element at the third element in my list. What number would I put here? 2. Yes, correct, because it always starts at 0. Seems trivial, but it's actually kind of tricky to remember in the beginning. Promise you. So that's an array. We're going to see more of those later tonight. There's one more concept I want to show you, and then we're going to get into more examples. And this is something called a hash, or in some cases a dictionary. A hash or a dictionary is basically a data structure that allows us to store key value pairs, meaning that we can have a format where we can access data by a key, and then it will, like, return us a value. Much like how a normal dictionary would work. Like, you look up a word and it gives you, like, the definition or the value of that word in a way. So as you see some examples down here, like a hash, the key could be login, and then the value of that key could be a username, a login name, right? And the key ID would yield the kind of ID of that user. So hashes are really, really powerful if we have a lot of complex data that we want to store. You can find a new variable here. It's our first hash. And they're declared by curly braces instead of square brackets. So then we could make our first key. I don't know.
Gustaf, can you just put the code up a little bit?
Which part? Oh, yeah, of course. Sorry. I'll make some more lines here or something.
Thanks.
let's focus on one thing at a time. We could call the first key workshop. We use this kind of rocket to assign a value to that key. And we can have another value, which is intro to programming, right? We can have another key in our hash, which could be, I don't know, number of attendees or something. Which I don't know, it might be an integer. I don't know how many people are in here, 40. And we have then declared or defined our first hash. So then if I were to put this, it will return the entire hash. Okay, so what's cool about this is that using the same kind of logic we saw before with the square brackets, we can actually ask Ruby for a specific value using its key to only return a specific part. So if I just wanted to get the workshop title in this case, I would use the workshop key, and it will return me the correlating value. If we run our program again, it will yield only that part. So, and of course, if you have, I don't know, thousands, even millions of different data in your database eventually, you can see how this would be very, very important to kind of query or ask for a specific part. So key value pairs, that's a hash. Really powerful. Right, so I mentioned conditionals earlier and how Booleans play a big part of this. So a conditional is basically a way to kind of evaluate things and kind of compare things and set conditions for when something should or shouldn't be executed. So in a basic form, we'd use an if statement. And this is just an illustration of what happens. So in the most basic form, it would be if something is true, like if A is true in this chart, do B. And in all other scenarios, if A is not true, we will do C. And that's kind of the end of a basic if statement. And of course, we could chain as much things. We can make this infinitely complex. We could say, if this is true, do this. If it's false, check against another condition. If that's false, check against another, and so on and so on and so on. So let's actually create our first conditional. We're going to create an if statement. So the way you can define it is if we put our condition, and then we also have to close it to an end. And on this line, we're going to put a condition, and then in between, if that condition is met, so this, like basically do this. So if this, do this. And then what could a condition be? Imagine we would have another variable that's called weather, let's say. And the weather is snowy. So then we could have our if statement here using this is called a comparison operator. So two equal signs is not an assignment operator, it's actually a comparison operator. So then we can say if the weather is identical to this here, so here we're referencing this variable by its name. So if this equals the comparison operator, snowy, we will do this. So then we could put something, like tell our user that, hey, it's snowy. You better stay indoors or something, right? Okay, so what if this were to change? Now it's not snowy anymore, it's raining. And if I were to run the same code, what would happen here? Nothing, right? Because now this condition on line 41 is not true anymore, meaning that this will never be executed. The program is still going to run. It's going to like define all the variables, assign everything. It's going to try to find a match. In this case, it's false. It's either true or false. So in this case, it's false. It's not snowy. So we're not going to do this line here. Which brings us to something called else. So if it isn't true, what should happen? In some cases, maybe we don't want anything to happen. Like maybe we only want to alert our users to snowy conditions. So if it's not snowy, we don't even want to bother with anything else. But in this case, we'll have to tell them that like we don't know.
Go to Spain. Go to Spain.
Right, that's always a sure bet, right? So we don't know the weather.
Because in Sweden it's snowing 6 months a year. So you
Yeah. So go to Spain or something. So in this case, the weather or the variable weather holds, like we have put the value rainy inside a box. We're going to go down to line 41, or Ruby's going to do this for us, of course. It's going to check if the weather is snowy using the comparison operator. We're going to do this right here, like in between. And if it's false, like in any other scenario, we're going to execute this, basically here. So now if I were to run this code again, okay, my bad, it will execute whatever is in the else. So, and if we wanted to make this a bit more complex, we could add something called an else if. So basically another condition within our if. So, and it will go line by line. It's really important to be aware of this kind of flow. And that's typically always how it works, top to bottom. So it's important in which order we put them. So it's going to check the first condition first. And if that one is true, like say it was snowy, it's going to stop. No more in this if statement is going to be evaluated in any way. But let's say here we actually want to check if it's rainy too, because that's not pleasant either. It's not as bad as snow, but. And we'll tell our user to bring an umbrella or something, right? Yeah, good catch, of course. So in this case, it still works. It's just that we can't see it, right? We're not returning it to the user in a meaningful way in this case. So yeah, good catch. So now we have our kind of first algorithm, like our if conditional statement, which will check against various things, return output based on a condition, or different conditions, basically. We have two conditions here. And in the other scenario, we're just going to say, we don't know whether we either, nice spelling, go to Spain, basically. All right, so this is an if statement in a very basic form. We could, of course, do different kind of mathematical operations. We could compare numbers, like integers, to each other. It doesn't have to be, in this case, we're comparing strings, right? So we're checking if this variable holds, like the box is storing the string rainy. That's kind of what we're doing, and then for snowy. But it could, of course, be if today is, I don't know, the month is, it's past August or something, and then we just always advise our users to stay indoors because after August it gets really cold or something. So it doesn't have to be a string, but in a very basic example, it might be a string. All right, so that's an if. Any questions on conditionals or if statements? Sure.
The hashtag do this that you have on the line 42.
Yeah.
This is just as a comment for you, right?
This is just a comment for all of us, basically. Exactly. So, and again, this was just to kind of make a point, but it's really good practice to leave comments, if not for yourself, but for people you're kind of collaborating with, because this is quite simple. Like just by reading it, you're going to say, okay, this does this. However, if you have something more complex, like an advanced algorithm, and you look at this 6 months from now, you're going to be like, what the hell did I do here? And that's basically how it works. So it's a really good practice to leave comments, and a lot of them basically, because there is no like downside to having more than one. So as much commenting as possible, if not for yourself, for your peers, or like if you're collaborating on something. Right. We're going to talk a bit about the concept of loops, which is a way to perform an action over and over, like looping over something. We're going to talk about two different kinds of loops. The first one being a while loop. So here we're combining the idea of having a conditional, like checking if something is true or not true, of course, like we could compare for both. And then we're going to execute a certain behavior over and over. So in this case, we're saying while A is true, like while something is true, do B. So we're going to go, like verify our condition. If it's true, we're going to do B. The program is going to go back up. Is A still true? Well, okay, do B again. And it's going to do this over and over and over until it's false. And then it's going to terminate our loop. So let's do our first while loop together. And I'm actually going to comment all of this out so we don't have to bother with output from previous things. So we could, let's add something to compare against. So we can add something, a variable we call counter, which is 0. And then we can say while our counter is less than 10, so it's a conditional, it's going to compare if the value of our counter variable is less than 10. We're going to do this. And of course we have to close it. So now, if I were to simply put our counter, or we could say, like with a string, we could say counter is less than 10. All right. So we define a new variable. We assigned with the assignment operator the integer 0, the value 0. And then here we're with a while loop. We're having a condition here. So while this is true, we're doing this. We're going to execute everything here. In this case, it's just one puts. It's just one line. We're going to go back up, evaluate again, and we're going to do this over and over. So in this case, do you have any guess what might happen if I were to run this?
It will keep on executing.
It will keep on executing, yes. So in this case, and it's kind of hard to see, I guess, but it's actually just printing this over and over and over and going crazy. And now we're actually stuck in something called an infinite loop. And this is really poor design. So if you ever come across a program that suddenly stops responding and really freezes, if it was coded by a really bad developer, this might be the cause, right? It's stuck in an infinite loop. It just keeps repeating a behavior over and over, and there is no way to get out of it. In this case, it would just keep on going until my battery dies or the program crashes or something. But luckily, we can kind of abort this and start over. So what would I have to do here in order for this to be meaningful? Well, we would have to somehow, for each iteration or each time we go in the loop, increment this. We would have to increase the value of our counter or something. Otherwise, this condition is going to be true in perpetuity because it's not changing. So we could use something called variable reassigning. So we could say for each iteration, each loop, we're saying that the variable counter is now, we're assigning the value of counter plus 1. So the previous value when we started the loop, plus 1. So for each iteration, we're going to check the condition, do this, we're going to put counter is less than 10. Line 63, we're actually reassigning it using the previous value plus 1. And it might actually, like if we do this, it might make more sense. So this is like just an incrementer operator, where you're saying that it's equal to what it was before plus 1, basically. So if I were to run this again, okay. Oh yeah. Be cautious to put the signs in the right order, of course, like respecting the syntax. So now in this case, our loop is a bit more meaningful. We're going into the loop. We're putting counters less than 10. Each time in the loop, we're incrementing the counter by 1. So we're adding, like increasing the integer by 1 for each iteration. And then we're going back up, evaluating again. And at the second iteration, it would have increased from 0 to 1. And it will check, is 0 or is 1 less than 10? Yes, it is. So we're going to execute again. And we're going to do this over and over until the counter hits, in this case, 9, because that's kind of the last point where we're going to see it's putting something. After that, it's equal to 10, which is not the condition here. We're checking if it's less than 10. And we could use something called string interpolation here. So we could actually, for each iteration, and this might make it a bit clearer, we could have our program print whatever it's currently, like the current value that the counter is holding. So now it's saying 0 is less than 10, and so on, up until 9, which makes sense because, yeah. So that's a while loop. And it's a great way to kind of iterate over, we want to produce a certain behavior, say, using a list or an array we saw before. So we could produce a certain behavior over and over and then increment or change something. So it's a great way to have the computer do a lot of heavy lifting for us with a repetitive behavior that would otherwise be taking us hours. Like imagine if we have a list of 1 million objects, or we wanted this counter to go to 1 million and not 10 or something. Any questions on while loops? We're going to see more examples of everything we've done tonight. We're going to do some exercises together. So hopefully we're going to combine different like data types, while loops, if statements, conditionals, and actually make some meaningful code. There is one other loop.
Do you have any examples of programs where this is actually coming to like being used?
Like a while loop. My guess would be like every single program there is. Maybe not a while loop, but some kind of loop. So imagine we would, like to answer your question, we can actually at the same time demo the other kind of loop, which is called a for loop. So a for loop actually allows us to have the same kind of repetitive behavior, but not using kind of an incrementer or a counter. So remember, all the way up here, we coded something called our first array. And this still lives, it's just that we haven't done anything with it for a while. So I could say for elements, so basically for each element in our first array. And then we would do this, right? So we could iterate over a list, or in this case, our first array. And for each element, so the keyword I'm using here, I could name it anything, it's just that we need to be consistent in here. We could perform a certain action. In this case, we know that our list it's not a very meaningful name, and this is actually bad practice. We should have called it whatever the names are actually referring to, students or name list or something. Our first array is a very poor name because it's hard for us down the line to understand what it should or actually does contain. But we could do something like, so now we could put each element in this. Oh, sorry, not a string, of course. And it will yield all our names. So what's cool about this? Well, of course, we could do something a bit more advanced, where we could use string interpolation again. And we could say, well, the element's going to be a name. We know that. So we could say a very warm welcome. And we can have it perform this kind of any kind of logic basically over and over for every element. And if it was a list of numbers, we could of course do any kind of mathematical operations for every number and then store it back in another list. Or so I mean, to answer your question, every time you want to do something like iterate over something, be it a list or any kind of hash or any kind of data, a loop is always very powerful. And we're going to use them more tonight to program. Or you shall see in a minute, actually. We're going to do a few exercises where loops is going to play an important role. So while loop and for loop.
Just Gustaf, if you allow me to answer this question. Let's imagine you're logged in a website. You go onto your browser, you go to the website again, and it says, hey Kathy, welcome back. In the background, something like this is running. So you have millions of those loops in any application or websites that's running in the background to interact between the database and what the user sees. And this is how it's querying the database. All right, so the next one actually is our exercise. So now we're going to together write a program that prints the numbers or puts the numbers 1 to 100. But whenever we come across a multiple of 3, we're going to print fizz. And whenever we come across a multiple of 5, we're going to print buzz. And whenever we come across a number that's a multiple of 3 and 5, both of them, we're going to print fizzbuzz. So basically, we can break this problem into 4 components, right? The 1 to 100 part, multiples of 3 should be fizz, multiples of 5 should be buzz, multiples of 3 and 5 should be fizzbuzz. So 4 different things. Now, as we were just on the topic of loops, as you can imagine, we would here use a loop. And we could do this with either a while loop or a for loop, whatever you prefer, really. Any suggestions?
For loop.
For loop, okay.
Yeah,
cool. So, for, and then we're going to have some kind of initialization variable that we're going to compare against. So for something in something, right? That's how we declare it. And in this case, but previously we used like 4 elements in our array. So what we could do here is basically put, there we go, an array with the numbers like this. So we would iterate over those numbers, and we could have it puts the number for each time. But of course, I don't want to write an array of 100 numbers. So we could take use of a concept called a range. So this here is a range, and it allows us to do basically specify a range of numbers. So here we're saying from 1 up until and like including 100. So for the number in this range, we can call this anything. It could be I or X or whatever we want to like, which makes sense. So we could call it I, for instance. We could say puts I. So now in our loop, it's gonna for every single number in our range, ranging from 1 to 100. It's simply going to print or puts that number. So this is basically the first part of our problem, right? Ruby is now returning 1 up until 100. All right, so far, not too bad.
I have a question.
Sure.
How does they know that this range is only about integers? Or is when you do a range, it's always only about integers? No.
Good question. In this case, I mean, the way we declare a float would be to like add a decimal point. Otherwise, Ruby's going to assume it's an integer. So, I mean, if I did something like this, it would be a range of floats, basically. Right. So that's the first part. We now have a program that prints the numbers 1 to 100. Now we're going to have to come up with a way to, whenever we come across a multiple of 3, we should print this instead of that number. So we would have to compare this, or for each iteration in our loop, we would have to run some sort of conditional, right?
If.
An if, correct. So
If I divide it by 3.
If I divide it by 3
Is
an equal number. Yes, 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 that would work, I guess. If I is divided by 3 is an equal number, yeah, why not? That would work. Another alternative that I was actually, so we would have our condition up here, right? And in every other scenario for now, we would just simply put the number. So another way of doing this is we could say if I, and then modulo, which is a mathematical operator, so not code specific in any way, 3, using the comparison operator, is 0. So if the remainder of dividing this number with 3 is 0, like if it's like divisible or multiple, like able to be a multiple of 3, we can do this, basically. Or we will do this. The program will do whatever's inside here for us. But the other way would work too, I guess. Like if you can divide it by 3 and it's an equal number. Why not? Yeah, that would work. So I guess coding in a lot of ways is just like problem solving. There's a lot of different ways to approach a problem and a lot of different solutions usually. So here we're saying if it's a multiple of 3, we should print this, right? So here we would say, oh, and I actually didn't mention this before, but as you might have noticed, throughout this workshop, I have been like indenting or putting different lines in different kind of horizontal positions. And this is just called indentation, and it's just for readability and enabling us to know that this that starts like in this vertical line here is part of our if statement, which is part of the wider for loop. So it would still work. I could put everything here and it would work just fine. So it's just for our own sake and for our like the people we might be collaborating with, so they can easier understand what we're doing. Readability, basically. Right, and if we run this program again, so for instance 99, I know for a fact it's a multiple of 3, right? And we now have this. So we have basically completed 2 parts of this four-part problem. Any questions so far, or does this make somewhat sense? All right, cool. We should return or print bus whenever it's a multiple of 5. We could, of course, use the same kind of logic. So if the remainder of modulo 5 is 0, we will put bus instead. And we would use an else if, right? So we'll have a new condition and then a new part of like the code that should be executed. So just bear in mind that this right here will be kind of evaluated, like each condition, until it gets a hit for each iteration of our loop. So first it's going to do for the first number in our range, which is 1. It's going to check if it's like a multiple of 3 basically, which it's not. So it's going to go down, evaluate this condition, which is also going to be false. So it's going to fall under else. We're always going to see the one here if we're implementing this correctly. Oh, of course, we need to actually tell it to do something, right? So in this case, it should be bus. And now we get 100, that's a multiple of 5, right? So we get bus. So far, it actually works. Now, for the next and final stage, we should, for any numbers that are multiples of both 3 and 5, we should print FizzBuzz, right? And how would we go about doing this? Any thoughts?
Condition.
We can have more conditions, yeah, so we can actually chain 2 conditions together, correct. So we can have another else if, and we know that this is working, so we could just copy this. And then we can use this, which basically says if this condition and the condition that comes here is true, execute whatever is in here on line 88. So then we could use both our conditions. And then we should put FizzBuzz, right? So now, do you think this would work?
No.
No. Okay, why?
Because it will print fields first,
Yes?
and then it will know.
No, it will work because of the cascading rule, right? Because the last line, it will overwrite the other ones.
So I mean, technically our code is like the condition is fine. It's something that has to do with what I mentioned earlier about the flow, right? So for each time in this iteration or in this loop, we're going to check the conditions one by one. And as soon as we get a hit, we're not going to evaluate anymore for that specific number. So for that loop, right? So say we were checking this against...
reorder it.
Exactly. We're going to have to reorder it because by the time we get here, numbers that are a multiple of 3 will already be picked up here. So they're not going to even reach this point. So in order for this to work, this statement would have to come first, before the other. Yes?
So I've been dabbling in some with JavaScript.
Okay.
And like HTML and CSS. And they have the opposite. The code that's in the bottom has the priority rule over the on the top. So it's kind of like opposite in this case, I guess.
No, JavaScript should still like, but you have something called asynchronous execution, so you could compare like the code will run asynchronously, but...
let's say like you take CSS and then you have like a background color of red and then you have like background color of blue.
Yeah.
It will still prioritize the blue color because it's the last line of code.
No, or I mean we could check afterwards for sure, but
because if I remember correctly, but I can be wrong of course, but if I remember correctly, that's how it prioritizes, like the syntax, the rules, right? So that's why I thought it would be correct in this case, but now it's like opposite.
Mm-hmm. Well, typically, I mean, just for efficiency reasons as well, like there is no point of the code carrying on in a loop if it already returns it like a true statement, because we're just checking if this is true, do this, and then we're like going down the hierarchy. And we could definitely have a look at that.
Maybe just a thought on this. For CSS, so CSS is all the front-end part, so really the design of the page. You would not necessarily have to run loops because the color of your page is something you assign and you leave as is. So basically your code was reference to the color that you want to assign to that page as a background color, for instance, and it will stay like this. It will not run any loop on the color.
Yeah.
So let's say the way the code reads doesn't really matter in that case because you have assigned that color to that page. Does that answer your question?
Yeah, I think so. Yeah.
All right, cool. So we have now basically reordered this. So we have our most like extensive condition first, and this should work. But we can take it line by line. So we're saying for each, in this case we're calling it I, but we could call it whatever. So for each kind of element in this case in our range, so for each number in our range, we're going to start with 1 because that's how we define our range. So we're going to say if I, and then like this module operator 3 is comparison operator 0 and 5. So if it's a number like a multiple of 3 and 5, we're going to put this. In the case of 1, it's going to return false, right? Because it's not. Same here. This is going to return false. So 1 is going to continue down. It's going to return false here as well. So it's going to fall under the else category. So we're just going to return 1. We should just see the number. And then for any number that's a multiple of 3 and 5, we have FizzBuzz, Fizz for a multiple of 3, and Buzz for a multiple of 5. And that seems to have worked. And what's actually quite cool about this is that we could now basically change our range here. So this code should work even if the range is like 1,000 or whatever. Like say we have a range from 1 to 50. This code should still work. And it does. So that's pretty cool. So we have an algorithm that will basically take a range, and you would never actually use this, but it would for any multiple of 3 and 5, print this bus, and then for a multiple of 3, this multiple of 5 bus. So this kind of logic can be, of course, improved upon so it actually produces meaningful result, but you still can get a feel for the kind of power of a loop where we can execute a behavior, combining that with conditionals, and getting output on a very big, in this case a range, but it could be a big chunk of data like different lists or names or like ordering stuff or any kind of magic basically. So that was our first exercise. Did it make sense for everyone or anything we should clarify? All right, cool. All right. We're going to talk about something called functions. In Ruby, they're actually called methods, but in JavaScript, for instance, they're called functions. And a function is basically, you can think of it as a black box where we would input something like a value. It would perform whatever logic we have coded, and it will give us something back. So it's kind of we could code a reusable piece of code for things that we're going to know that are going to happen over and over, so we don't have to repeat ourselves. And it would take usually an input, doesn't have to, but it would usually take like an input, do some kind of logic to this input, and then produce an output. So an example would be square and then x. So in this case, the method function is called square. It has one parameter, x, and we could actually code this and see how it would look like. And I mean, if I were to guess, this would provide the square of x, right? That's, if you named it correctly, what it should do. So when we declare or define a new variable, we use the key name def. We have the method name, so in this case, square. And then it has one parameter. So when we define it, it's called a parameter, but when we later use this method, we actually pass it what's called an argument. So it's just different words, but basically we're talking about the same thing. We're providing it with an argument, but it has one parameter. So in this case, we wanted to somehow, looking at this black box here, we should take an input, in this case x, we should perform something with it, and we should provide an output back to the program. So we would return it, and how would you square a number? You would basically
multiply by itself.
Yes. So we could say x times x, and that's our first method. So now we have a reusable piece of code, simple as it may be, that will basically we'll pass it an argument, and it will always perform this kind of logic, and it will return us the result. And again, just to be clear, we could call this whatever, basically. I guess x is a good number, because in math, that usually would reference like an unknown number. But as long as we're consistent, both here in our definition up here, and inside our method, we can call it num or any kind of thing. So as long as we're consistent, it will work. Now, if we wanted to use this, just to either actually use it or make sure it works, how would we call this? Let's imagine we would put the result, and how do you think we would call a method? Like, how would we actually call upon it to do some work for us? How would you normally call a person? We would call it by his or her name. So same here. We could call our method by its name. We pass it an argument. So any kind of number, 10. And then what's 10 squared? It's 100. So it works. So now we have our first method that we can reuse throughout our program that will always return us the square value of whatever number we pass it as an argument. So this is a very basic method, but imagine you would have more complex things, like you want to do a certain behavior to greet your users when they sign in or anything like that. We can have a method that simply takes their name and then returns a greeting or something. So it's a powerful way we don't have to repeat ourselves, basically. Instead of writing that over and over, the same kind of logic, if we need to square numbers in our program, we can have this kind of a method basically that's reusable and always available. We simply have to call its name and pass it an argument. We're going to look at one more example. Right, so another method, full_name. It has, in this case, 2 parameters, so it takes 2 arguments, first and last. We would again define it, name it. Let's call it full name. It's a good name. We would take first and last, basically. And then we should probably somehow combine the 2, right? So it takes 2 parameters. We pass it 2 arguments, a first and a last name. And presumably it would return us the full name. So basically, we give it 2 strings, or 2 pieces of text in this case, 2 names, and it would return us a full name. So we could either do something like return first plus last. And then again, if you wanted to call this, and I actually want to display the results, I'll use puts, full name. And we're going to pass it Eric as first, and I don't know, Eric as last. And now it actually returns us a full name. So now this is not ideal because, I mean, it actually returned us the full name, yes, but there is no space here. So we would have to somehow either add like an empty string like this. So we would like concatenate the entire thing and adding a space as well. And that's better. Or just to be even cleaner in this, we could use string interpolation we saw before and include a space in our code here, which is between quotation marks. So it's still a string, but we're using this syntax here to kind of let Ruby know that now we're not talking in characters anymore. We're actually grabbing another variable. We're grabbing like an object, right? So in this case, last. And it would return us the full name with a space. All right, makes sense? Yeah. And of course, we might want to have another method that's like greeting or something, where it would take a name and then produce some kind of behavior to kind of greet the user or ask the user for any kind of thing. So you can use this basically for anything where you want to have a predictable behavior, so like an output based on an input. And I mean, as I mentioned earlier, a method doesn't even have to take a parameter. It could basically be a shorter way, so we don't have to repeat ourselves and writing long pieces of strings or code over and over. So we could just have a method that's called, in this case, greeting, that would just say, hi there, welcome. And then we could later on in our program call this greeting without passing it any arguments. It doesn't take any parameters, but it would still produce whatever is inside the method. And it can save us a lot of time if we have more complex method, right? So we don't have to like reinvent the wheel over and over. Right. It's time for another exercise. And in this case, we're actually going to code a method that will translate a given DNA. So it should work for any kind of DNA. And the output should be RNA. So basically, DNA is the primary information storage molecule in biological systems. It is composed of 4 nucleic acid bases: guanine, cytosine, adenine, and thymine. RNA, on the other hand, is the primary messenger molecule in cells and differs slightly from DNA. It contains no thymine, which is in this case replaced by uracil. This is as much as I know about DNA, but we're going to attempt this anyway. And they have even we're kind enough here to include like an example. So if we're calling our method and we're passing it to argument GCAT, the output or the return should be GCAU. So we're going to have to come up with a way to look at the input, like the argument that's passed to our method, and then whenever we come across thymine, we should replace it with uracil. And of course, we could make the assumption that DNA is always composed in this order, so it's always going to end with a T, like the thymine comes in the end. I don't know if that's the case, so we're going to have to come up with a way to verify or check every letter regardless of the order. and then we should like return that to the user as RNA. So replace the thymine with uracil, whatever those are. All right, we could actually copy this text, so we have it here with us. We can make sure to comment this out. Okay. All right, cool. Now we have the instructions. Okay, so we need to create a function that translates a given RNA string into RNA. All right, so first we need to define it. We should name it in a kind of way that it's easy to understand what this does. So I think the naming convention here, RNA to, or DNA to RNA, is fine. It should only take one, it has one parameter, so it only takes one argument, which should be DNA. And then we should output or return RNA, right? So let's just start by seeing how this would work. So we could call our method. And apparently this is a format DNA comes in. So far we should call the method, pass it the argument GCAT as a string. And so far we're only returning it, so it should just return us what we put. All right, so here it throws an error. And Ruby is kind enough to kind of point it out for us. So it says on line 156. And it says, did you mean RNA? Yes, of course, because that's our input here, right? And I only want to, at this point, see what gets in and out. Right. So now we have the method actually is taking the argument of the DNA here and simply is returning it as is. So remember in the very beginning I told you that a string is basically a sequence of characters, meaning that we could actually split a string into separate elements. So we could easily convert it into an array. Once it's an array, we can use one of the loops we saw before, and then we could perform action to each letter and then do some kind of logic with it and then store it back. And eventually we could have our translation. So that's basically what we're going to do. We're going to have a new variable inside our method. We could call it DNA array, because that's what it's going to be. We're going to take the parameter here, so whatever it's passed as an argument. And then we can tell Ruby to actually, like, we're expecting a string here, so we'll tell Ruby to split this. And the quotation mark here means basically that we're going to split it by each character. If I were to do something like this, we would split it by each comma or something. But in this case, we want to split it letter by letter, right? So now it would actually return each character on its own, meaning that it's now easier for us to kind of apply a logic on letter or character for character, basically. All right. So, and again, as I mentioned previously, sometimes it can be meaningful to have an empty array if we want to store something back. So what we're going to attempt here is splitting it up, checking it letter by letter, storing it into a new list. And in the case of thymine, we're going to, of course, attempt to replace it with uracil. And then eventually we're going to hand that back to the user as RNA and not DNA. So we could here already declare an empty array, which is ready to be filled with new information. All right, so we have seen two kinds of loops. We could use any one. So I don't know if you have a preference of for or while. Any of the two would work. No? All right. We'll use a for.
We'll try while.
Ah.
Last time we used for, right? Now let's try while loop.
All right. Sure. So while something is true, we're going to execute a certain behavior. So we would have to somehow keep track of our iteration here. So we could introduce a counter, as we saw before. We have somehow to make sure we're not entering an infinite loop. So while our counter is less, and then we can actually ask Ruby, well, okay, so it's taking in this information when we call the method. We're going to split it. So it's character by character. Store that in a variable called DNA array. So basically what we can do here is we can ask the while loop to, while the counter is less than the length or like the amount of elements in our array. So we could say that while our counter is less than our DNA array dot length, so we're comparing, like, we're going to increment the counter, of course. So we're comparing for each time we enter the loop if the counter is still less than the length of our array. Okay? And then, of course, here we would call different elements in our array. And actually using a for loop would be slightly simpler because, as you saw before, it would kind of keep track of how many elements we have. So we'll have slightly more lines of code here, but it should, of course, work. So yes, two. And then here we would call the index. Well, fortunately for us, we have our counter, which also happens to be an integer. So we can use that to kind of access a specific element by its index in our array. So if I were to run this now, what would happen? Infinite loop again, right? Because we're not incrementing our while counter. So it's going to compare over and over while our counter is less than the length of our DNA array. It's going to continue to execute. And actually, can anyone tell me what the length of our array should be? Based on that, we're providing us with a string of 4 characters, and we're splitting those up so each character is one element. 4, yeah, correct. So, and those indexes would range from 0 till 3. Yes. All right. So, of course, we'd have to increment this as we did before. That's better. All right, cool. So now we're actually iterating over each character in our new array. The next step, of course, would be to, for each time we enter a loop, we would compare the current letter we're looking at. And if it's timeline, we should replace it with U or so. So any T should be replaced with a U. So now we're going to use conditional again, right? So in our loop, we would have an if. So an if condition and, so we do it. So we could again call or using our DNA array with the counter as a way to access specific element, using that as like our index since it's going to increment. Call that with a counter. And what do we want to check here? So if the letter matches what, we should replace it. So if the letter is
T.
Exactly. So for each iteration, we're going to compare the current letter that we're in our loop iterating over. And if it matches exactly, using our comparison operator, a T, we should replace it with a U. And here I actually already defined a new list, a new array. So we could easily store our information back to a new list that we then could, of course, return to the user. So we should basically replace, or like instead use A or U. And in any other scenario, we should basically just return the letter, right? Because that's the only thing that changes between DNA and RNA. Thymic should be uracil. So in any other scenario, we should just return it. So we could use our new array, our RNA array. And this right here is just like 2 chevrons, which means like to shovel in new content in our array. And we would put the string U. For any other scenario, we would simply use the same kind of chevrons. And
It's the array, right? DNA array.
Huh?
You are using the function name.
Yes, very good catch. Thanks. Right, so in any other scenario, we're just going to take,
In if 163 also, I guess.
Say again?
In 163 line also, it should be array, DNA. 163 flow.
Yes.
You are calling.
Yeah. Good catch. All right, and then in any other scenario, like if it's not a T, we should basically just put that into our array, our new list, which is our RNA. And then basically, it's becoming very long, but then at the end of this, we would return the user with our RNA. Let's try to compact this slightly. All right, so we're defining a new method. DNA to RNA has 1 parameter, meaning we can pass it 1 argument. It should be DNA. We're then taking that input and performing a split. So we're gonna have separate elements, a list of like each character as its own element, storing that in our DNA like variable in our method. We're defining an empty array just to make sure we can store the RNA later on. We have a counter just because we decided to use this while loop. And then we're gonna make sure that we don't get stuck in an infinite loop by comparing our counter with the length of our DNA array. So I don't know, maybe DNA can only come in the form of 4 characters. Maybe it can come in the form of 100. I'm not sure. But by using this logic, we actually make sure that it's gonna go up until the point of the length, but not any further. And then we have our conditional here inside our loop. So if in our DNA array, using our counter, which is always gonna be an integer, to access, like at first it's gonna start with a 0, right, for our first iteration. It's gonna access the first element in our array, which should be a G. It's going to compare, is this the character or T for thymine? We will put the character U for uracil in our RNA array instead. In any other scenario, we're simply just going to return that letter. We're going to increment the counter by 1, and that's the end of our loop. Finally, we're returning this RNA array to the user. All right, let's see if this works. It seems to have worked, right? So before, actually, I'm calling our method here with GCAT, and it's actually returning us GCAU. So we're actually managing to replace the thymine with uracil. So pretty cool.
I have a question.
Yes, please.
Why do you put two symbols like this instead of an equal between like
here?
Yeah.
Right.
Oh,
so
the one below. RNA array. Yeah. Why can't we put just an equal?
Here.
Oh.
Because technically we're not saying that we're not using the assignment operator to say that our RNA array is like not equal, but we're not assigning a value, we're adding a value, right? If I was assigning it, then it would just be, for each iteration, we would reassign it. We would not add stuff. So what this operator does here is shoveling in or adding more elements. So if I did this, for each iteration, it's just going to store that one character, not adding it to our list.
So it's saying to find T's and replace it with a U.
That was the objective, yes. And then, of course, we could have done this way, way simpler if we knew, let's say that DNA is always coming in this form. Like, we could have come up with a different logic to always replace the last character. But now I don't know that, so we had to like work our way around that to make sure that this should work for any kind of,
So basically, now that we defined the function,
Mhm.
we could use it, we could put like what's in 153, instead of DNA with the orange letters, you could put anything in there, like any sequence of letters that are using these 4 letters, and then you could like do the same thing together.
Correct. So we have coded a piece of code here, like a method, which includes our while loop, our conditionals for the if, and then returning it as a new list. So now down here, when we're actually calling this method, we're passing it exactly what the challenge was asking of us, ECAT, but let's say I was calling it with ECAT, TT or something. This should still work. Our program should still go through the letters one by one and make sure that whenever there's a thymine, it should be replaced by uracil. And it does work. Now, do you have any kind of critique of this program, apart from it being a bit bulky and long?
Well, we know you did it on to check it.
Yeah, well, okay. But so if we actually read our instructions here, calling our method with GCAT should simply return GCAU. So if we try this again, we're technically not living up to that, right? Because we're actually returning line by line our list. So in that sense, we have failed. And just as string is a sequence of characters that we easily can split up into a list, an array, we could of course do the other way around. We could say to a list that, hey, we now want to like join this, like every element should be joined together and be represented as a string instead of an array. So on our DNA array here, we could simply do .join, and Ruby will just concatenate this for us. So every element in their order as they come will be joined as a string. So now we have basically a method here that would take DNA in any way or form. If it can come in another form, I don't know. But it will take it in any way or form and perform this conversion to RNA. So if we wanted to, as you can see, this became quite long. And if for whatever reason in the app that we were working on, we would need this kind of logic, instead of coding it over and over and over, we would have this method pre-coded and available. We just simply have to call its name, pass it an argument, like a DNA to convert, and it would do the heavy lifting for us. So this really showcases like the power of methods. Yeah, please.
I was just thinking, as an absolute beginner, and like, how would you remember all the operators? Because it's not really intuitive to me. To kind of, does it give you? I saw that you could see the syntax error if you actually did a mistake, but like, yeah.
Like what kind of operators? Like
I was thinking all of them, and like the dots and what they actually, you know.
So what's really good about Ruby in particular is that whenever you want to do something, there is like a very extensive community online. So let's just say, for instance, here, this last part, we wanted to combine an array into a string, right? So let's just, and hopefully this will yield some meaningful results, but like convert string, or convert array to string, Ruby. Let's see. And here it would basically outline, maybe this was about, let's take the first example, see if it was better. All right, so here, this is a website called Stack Overflow, which you're gonna become best friends with if you ever get into programming. So basically it's like a huge, huge forum where people ask questions, and you'd be surprised how much like thorough and extensive answers you will get by people just volunteering their time. So in this case, this guy is saying I have a Ruby array with blah, blah, blah. I want to convert it like to a string in this format. How would I do that? And then this guy here tells us that we can use the .join method, and it would simply output this, right? So whenever you're in doubt, like Googling will take you so far. So I don't know if I answered your question, but basically, like, I mean, the point being, like, never be afraid to ask, I guess. But there is a few like basic operators, of course, that you're gonna have to learn by heart, and then the more complex it becomes, like even the most experienced developers Google all the time. That's reality. But I think the majority of them are quite, like, once you've used them just for a few hours or a couple of times, you're gonna find that they're quite intuitive after all. Yeah.
Generally, if you have an issue or something you don't know, millions of people had that situation before. And if you ask Google in a very simple way, it will send you to Stack Overflow and you'll have really good documentation. So any of the concepts that you've seen tonight, even if you don't know a core concept but you're looking at doing something in your code, simply ask Google like a simple sentence, you'll get a lot of value out of that. And very experienced developers do that all day.
And now actually to your previous point, like we did all of this and it took us quite a while, but maybe we could have asked Google or like just went on Google to search for how to replace a specific letter in a string or anything like that. And I actually looked this up beforehand, so I happen to know that there is a built-in operator called gsub, which will basically take, in this case, the DNR input, and we could say that we want to replace T with a U. So this tiny line here saved us all this work. It will do just as well. So, I mean, again, never be afraid to ask is a big part of this. And you can spend a lot of time trying to work around and make sure you get every kind of corner case. In this case, this was quite messy. We could probably have structured it in a better way, which, by the way, is known as refactoring. A lot of people usually, or at least beginners, try to get it working first, and then you would kind of clean up your mess and make it look pretty. Half of the time you would break it again, so then you have to go back and make it work. But to actually get it working is the first really solid step, of course. But the point being, never be afraid to kind of look for the answer before, because as you said, like 1 million people would have come across similar problems before. So never be afraid to Google, basically. Right. So I was thinking to either if there's one more like bigger exercise, or if we should like go back to some key areas if you want to like have a bigger look at loops or while or conditionals or any kind of thing, or if we should carry on and do some more examples, or all right. So is there any kind of thing we went through tonight that we should get a bit more clarity on? Or any kind of questions, really?
I think some more like how do you apply certain the examples here, like in real life?
Sorry?
How would you apply some of the functions here in real life? Like, do you have some? We were discussing like cleaning lists or like filtering and.
I mean, let's imagine we would work as consultants for a pharmaceutical company or anything, right? We would then need to, I guess, do this on a daily basis. And instead of someone like running this on, I don't know how you would do it, but like in the simplest form, like pen and paper, we could very easily come up with a way to have a converter for them. So we could introduce a tool that would always translate, in this case, DNA to RNA for any kind of given output or input, and it would give the accurate output. As for the other examples, I mean, what was actually the other challenge? It was like the numbers. Well, let's say you wanted to search for patterns or something. You have a huge database or something, and you want to like check conditions rapidly on a lot of different things without doing it manually. That kind of loops and like checking conditions for logical numbers would be very useful. So I mean, it could really be anything. And I think just getting started with coding, writing a few lines of code and like making sure you get a return is just usually a lot of fun, and you learn a lot on the way. And we didn't get into covering that tonight, but what we could also do is ask the user or prompt the user for feedback. So we could actually like very, very simply do this here. So we could put something and say input DNA to convert. Oh yeah, sorry. Input DNA to convert. We would use something, just a new variable called user input. In Ruby, it's called getJump. That's how we let Ruby know that we're going to prompt the user for something. And then we're going to later on call our method with the user input instead of a predetermined string. And now if we run our program, it will ask us for DNA, like input DNA to convert. You could use the same thing again, UCAT. And it will, assuming we put it, return us with the equivalent of the equivalent RNA for that DNA. So we could actually very easily build programs that we can interact with, that asks us for things. We compute different kinds of logic. We give the user back an output, which is really powerful. And what you've seen here tonight, of course, is just kind of the basic logic in the back end. This would be a horrible user experience if your users were using a terminal. So this is like using for development and testing and so on. And in a real life, you would use, like in the case of web development, you would of course have HTML and like an actual web page with an application that looks hopefully nicer than this. But this is just a taste for like coding and different, read through some basics basically. All right.
All right. Thanks, Gustaf. Thank you. So again, this evening we only very much scratched the surface. So to your question, this is just like the basics of the basics, but this is the kind of logic that interacts in the background when you're on a website, when you're entering stuff on a website, when you're looking for stuff. A website is very much a set of repetitive behavior that the user follows. Every time you click on that module, it takes you to that page. And in the background, the programs are written in the way that we've seen tonight. So how was it? Did you learn something this evening? Yeah? Functions, loops, variables, iteration. Those are common, let's say, core concepts that are beyond Ruby. We showed you Ruby this evening because that's one of the most user-friendly syntax and language. Doing that in JavaScript, for instance, or in Python are way more difficult from a syntax point of view, so less easy for a beginner to understand. And that's also why we teach Ruby, because Ruby is very forgiving. Your code does not break, it gives you feedback. And Ruby is pretty simple to write. There is some very difficult languages that are extremely difficult to learn the syntax and let alone start using. And that's why Ruby is great for that, to build very fast some applications. So this is the end for this evening. Just some information. We'll have a lot of very cool workshops for you guys until Christmas. We have an information session, but you heard most of it today. We have JavaScript. JavaScript is, there's a lot of hype around JavaScript. It runs in the back end, it runs in the front end. We'll have a full workshop on October 31st about that with a very experienced JavaScript developer, a machine learning engineer working here in Stockholm. For the entrepreneurs in the room, we'll have a very interesting one on November 18th about product management. So how do you go about creating a web product? Where do you start? What is the user journey? What kind of interaction do you want to get? What kind of call to action? So how a product manager also works in a tech company. And we'll have also on December 2nd, APIs for beginners. APIs is something that if you don't know web development, you don't really know about, but they are everywhere. API is any ways that two different tech products interact, and it's basically how a product goes and fetches information from another one. And it's actually quite fascinating how it works because it creates bridges between millions of tech applications. Not on the screen, but we are organizing also front-end related workshops, so on web design, and we have a few very skilled instructors for you. So check out Meetup, Wagon Stockholm. This is not the final schedule. There will be more new workshops. And yeah, and check out the social media, of course. Our first bootcamp, so the real program that we will run, will start as of February next year. So we are going through the recruitment of our first Stockholm students. We will create the alumni community here in Stockholm. So you can check that on the website, or always come and talk to me. And to finish tonight, I'd like to leave some thoughts with you. Some thoughts and some quotes from interesting people. If coders don't run the world, they run the things that run the world. In today's society and environment, that's very much so. Everybody's on digital, everybody's using application, everybody's using technology, but actually very few people really understand how it works. And if you do and you have a clue, you have an edge over a lot of other people. One that I really like from the author of the book called Sapiens, Yuval Noah Harari, is the art of reinvention will be the most critical skill of the century. And I could not agree more with that. Today the workplace is changing. Your ability to adapt, to learn, and to keep learning is absolutely key. And coding teaches you how to think. I didn't come up with that, Steve Jobs did. And it's actually absolutely true. So thank you very much for coming tonight. If you have any questions, please come and talk to me and Gustaf. We both went through this experience. We're happy to answer your questions. And follow us on social media and come up to the next workshop. We'll be really glad to see you guys again. Thank you.